Hi, Thomas. Welcome back.
Hi, Adam. Glad to be here. So early morning here, and yeah.
Yeah, not that early. It's just 9 a.m.
Oh yeah, for me, this is early because I'm usually more working on Californian time zone.
The next time we do later.
Yeah, exactly.
About drama. What I heard is that GraalVM focuses less on Java, and they decoupled the GraalVM releases from Java releases. This is what I heard on the drama from Devox last year, and we try to clarify that. So now it's, I think, time to talk about it.
Yeah, no, absolutely. I mean, I think to be very clear, GraalVM, we are as a project. We always in our history have been a polyglot project. GraalVM always had as it's part of its mission to support multiple languages. So there's nothing new there. There's certainly the case that we are focusing more on languages also other than Java, like specifically Python, because Python is becoming super popular because of all the AI hype. And but at the same time, we are not abandoning our existing Java users or people using Java or JVM based languages like Kotlin. And I mean, a lot of these users are very happy with GraalVM as a tool to deploy their applications, and our roadmap in this area is also fully intact, and we are not stopping anything in this area.
So my understanding is there are two things, right? So GraalVM as an OpenJDK project, as a JDK, and GraalVM as a native image. So what I'm understanding that you are decoupling the OpenJDK from the OpenJDK cadence. So there is not necessarily the case that every new LTS of Oracle OpenJDK or whatever OpenJDK will be synced with GraalVM, right? So this is what happened actually.
Yes, and this specifically about we are not fully in sync with every new Java release anymore, which means that we might be lagging slightly behind the Java release. And we do not plan to release a version of GraalVM with non-LTS releases of Java. This means when Java 26, for example, is out, we will keep on GraalVM 25. This type of release cadence, yes, this is a change, but it's at the same time this is what we had earlier in the project, like before we were aligning more closely with the Java release a couple of years ago. We also focused on Java LTS releases only. Which is the primary part of our user base in any case, and this change actually helps us save some amount of engineering time in the GraalVM project, because it means we do not need to chase the tip of the OpenJDK development on a weekly basis, which we did before. And yes, so this is a change in cadence, and also there's a change in terms of and this was also primarily what this blog post from the Java product manager was about, is that the newer versions of GraalVM starting from 25 are no longer part of the Java subscription support offering. But this pertains primarily to people who are getting their commercial support offerings from.
You're talking about Oracle subscriptions.
Oracle, right? Yes, exactly. Yes. And but at the same time, I think it's important to mention here that GraalVM, while the vast majority of the GraalVM team is employed at Oracle, GraalVM is a multi-vendor project. We have a community edition. We have third-party vendors, including Red Hat, Bellsoft, Microdoc, who are creating their own editions. And also, I mean, there was a blog post by Red Hat how they will continue, for example, their path on native execution, because it's so important for the performance characteristics of Quarkus.
Yeah, this is what I also understood. So I arrived on Devoxx a bit late, and someone say, "You heard about GraalVM breaking news?" And I look at the blog post. I go, "Okay, it's not that significant for me, because usually what happens if someone runs GraalVM in production, they bought support from Oracle or from Red Hat, for instance. So you almost have to do this for political and organizational purposes, not necessary from technical purposes. So, but what it means, could I try to compile recent JDK 26 with native image, or it won't work? You know what I mean?
Yeah, I understand. It might work. So I mean, when we talk about Java 26, there is first the question of the source source level of the Java version, right? And then there's a question of the JVM level of the Java version. And in many scenarios, you can actually take a Java 26 application and run it on a JDK that is Java 25, and for example, use Java C to compile something with a Java 26 language feature down into Java 25. This is something that's also already happening right now in some scenarios where people are they might want to use a language specific feature from a new Java version, but they want to run on an older LTS in production. So this type of running such an application would work. But if there are runtime innovations in Java 26 or 27, for example, you would have to wait for us to adopt the next Java LTS release, which is Java 29, before you can then again use native image as a deployment option.
So I would say for open source project, you have to know the change, and for enterprise projects right now is not a significant change, because Java 25 LTS is out, and my understanding is that the GraalVM won't be synced with the next LTS, but eventually will come out. It's not like it will come immediately, but you will still provide a version which is LTS compatible. So what is going to be 28, yes. 27?
Same. We'll sync again when it's 29. So when there's 29, there will be a larger sync on the versions, and it might take us a few months maybe. So we might not exactly release on Java 29 version, but a few months afterwards you can expect a GraalVM release. And yeah, I mean, GraalVM in general, so native image is its most popular feature, of course, right? And the recent developments in this space, specifically around the price of memory, for example, is actually makes GraalVM even more attractive. I mean, we saw that memory memory prices are going up crazy because of this shortage, and I like to just underline here that GraalVM native image, yes, the startup is awesome, which is nice. You get instant startup, but another benefit of it is actually that you execute with a lower memory consumption, and this means you can select on function services a smaller instance with less memory, and just in general save memory across the board. So this type of savings, they actually become more attractive in the current environment, with memory prices having gone through the roof.
It was already attractive in, I just look it up, 2022. So there was on this podcast. So what they did is there was an insurance in Switzerland. They migrated from JBoss to Quarkus on GraalVM on OpenShift. And they were able to have a significant savings because they could pack more services on the existing hardware. So it was, and they had the hardware. They didn't have to buy anything. They just saved money by migrating to JBoss to a Linux, which is Quarkus, with GraalVM. So, and now it's even more significant because of the RAM prices. But back then was already a success story. So I had an interview with Daniel Lipp on this podcast, and was an interesting one. Mm-hmm. But if I would pick, the Oracle Enterprise GraalVM edition, would I get the LTS sooner if I would pay, or not?
No, it's the same. It's the same.
The same.
And there's no changes with respect to that. Now at the moment, if you are let's say you are on GraalVM 25, you can use GraalVM Enterprise under the GFTC license, which is this free license, and there is no changes there.
Okay, so maybe in future, who knows? Because I think it would be interesting for some clients to say, okay, I would really like to have it, and if they pay, I don't know if there is like a premium support or something like this, could be an interesting product for Oracle to
sure. But in general, I mean, the GraalVM team, in terms of product strategy, etc., one important thing to note there is that the GraalVM team is now much more closely aligned with the Oracle database team. We think of ourselves as part of the Oracle database organization, and so we already had GraalVM technology used a lot within database because of Oracle Multilingual engine is the feature called in the Oracle database that runs GraalVM. Here in this area, we are increasing our alignment and investments quite a bit, because Multilingual engine previously was executing JavaScript only, and we are currently expanding this to execute Python and other languages. And this whole setup means that moving forward, the areas where you will see from us more innovation and more enterprise type of innovation is aligned with the Oracle database, and less so we're seeing GraalVM here less as a kind of a standalone runtime, but we really wanna offer new enterprise features that are aligned and combined with the Oracle database. And this means specifically if you're an Oracle database customer, for example, or user, then you can expect more interesting features that are synergizing here between Oracle database and GraalVM runtime.
Also MySQL or just Oracle?
It's not only Oracle. MySQL has a feature that is also MLE, that is also an MLE integration, multilingual engine integration. So it's not only Oracle, it's Oracle and MySQL.
That's interesting. And this is what I missed. As Oracle bought Java, I thought, we get stellar JDBC on steroids and Java in the database, and nothing happened, basically. And now you're coming with Python. So Java would be also nice to have, Java stored procedures. This would be great because with Java 25, we can run source code, right? Which is incredible. So I would say this would also be cool to move some business logic from application servers back to database. I think stored procedures are widely underestimated thing. And they, 10 years ago, they were like, no one wanted to have stored procedures for unknown reasons. They said, okay, the business logic belongs to application servers, not to databases. But I think data gravity, right? If you have a huge amount of data, I would absolutely put some Java code to the database.
Yes, I totally agree with that. And we are working on having native images itself, which then means JVM-based languages that can compile into native images to be available also as stored procedures. And if you talk about stored procedures and why they are hated, I think there are some aspects to that we can mitigate. I mean, one is the language aspect, of course. Currently, stored procedures you would primarily write in a language that you are not familiar with, so that's different from your typical backend or frontend. Yeah, PL SQL, exactly. It's different from all other languages that you're working with. So that's one objection that with Oracle Multilingual engine we are arguing against, and we can mitigate. The other aspect to it is a question of the development cycle and the the deployment cycle. So one other aspect that makes store procedures sometimes difficult to work with is that you need your database administrator to deploy the store procedure definition before you can run it and use it, right? And in this area, one of the directions we are thinking in is that you can even like ship a Lambda from your client application to the database and execute it there if it's more beneficial, for example.
Yeah, this
without defining a special store procedure. The procedure only exists temporarily for the current database session. And then you can package your store procedure and program it together with your application, and it doesn't feel weird. And this is compared to kind of deploying it separately.
We had already a chat with Gerald Wenzel about that. And I think there are two opposite architectures, and both are fine. So we can treat the database as a dump store. It's just storage, consistent store, and nothing else, and put the entire logic on the application server. But you could, I would say, Oracle is almost like an operating system, right? Everything is in place. It's just incredible what it can achieve. So for me, it would be the reverse also possible, that we put the entire business logic to database and even expose an HTTP endpoint. And what we get then is something like serverless, right? We could run pieces of Java code like isolates in GraalVM on the Oracle database with business logic. And this will be highly efficient because the database has to run all the time, anywhere, regardless, because we cannot just stop the database. We could, but it wouldn't make sense here. And our business logic, we could, start a GraalVM process and then kill it. It will be highly isolated and highly secure execution model, right?
Yes. And specifically, this like start the process and kill it is a feature with Graal native image that we are also like improving in the future because we want a very efficient scale to zero. And here again, the database comes in handy because as you scale to zero your application, you want to store your application's definition somewhere. And not only the application's definitions, one of the areas my team is researching and developing new elements on is in the area of snapshotting applications. You can think of it something a little bit similar like Creo, but it's
Crack.
more Crack. Yes, exactly. Our approach is slightly different. It runs user space only. It doesn't require kernel privileges, and it's a bit more lightweight than these other alternatives. But we have a system where we can actually snapshot native images and also Python programs as they are running, and then continue running from that point. And in that scenario, again, making your database into your application server makes even more sense because a lot of services are idling in many scenarios. And when you run it in the database and you store the snapshots in the database to continue executing from there, then your cold start is going to be really, really good to the extent that you don't have to keep those very often. You don't need to keep those applications in memory. So this is definitely yes. So yeah, like your thinking in this area is actually very much aligned with what we are currently developing with quite some urgency as the next step for the GraalVM project. Because if you think about GraalVM native image, we are continuing improving it, but to a certain extent the technology is quite mature already. We are continuing improving on compatibility. We are making the metrics even a little bit better, a little bit less memory, a little bit faster startup and so on. But here the gains are kind of incremental. And what we are seeing now as the next big step in the GraalVM project in terms of innovation is exactly those two aspects: the aspect of how you deploy efficiently the native image. Because it doesn't make sense to create a native image and then pack it into a Docker container and run it on Kubernetes.
Exactly.
Because like you created something very small and nice and neat and lean, and then you pack it into something that has a huge overhead.
And it's not as isolated, right?
And it's not as isolated at the same time. And then the second aspect is this, like, how can we deploy this in the database with low overheads, fast cold start, and yeah, part of the GraalVM team is also building some higher level service around this that will allow us to run in the database like some serverless type of workloads then directly. Yeah. And the Oracle database already has some features that are helping us with that a little bit. There is ORDS, which is this REST service on the Oracle database, where you can access the Oracle database via REST. And what we are building is a generalization of that feature to be a general execution platform with efficient scale to zero and fast cold start with native images.
This is actually, then you could consider the database as a cloud, right? So this is what you talk about, because in a cloud you usually have to have always data store to be stateless. And we say, okay, if we need a database and the database is capable, why not to put everything in a database? And database has to run, the entire data store, and we can use this runtime, so like Java-based runtime or GraalVM-based runtime, to execute functions or functions as service efficiently with scale to zero, which is we get a cloud.
Yes, correct. Yes, you get a small version of a cloud. That's highly efficient, and then all you need is an Oracle database service, which you get already, by the way, not only on OCI but Oracle database you get nowadays as a service also available on Azure, on Google Cloud, and on AWS as well.
And on premise as well, right? I could just done.
Yeah, I mean, even on premise, you can have you can have clouded customer with running Oracle database autonomous service.
And even crazier, what you could do with that, because Oracle has a Golden Gate like replication. What you could have is like two databases which are sync with each other, for instance. And you can have one function which goes to this database, and in another region or in another cluster, you can receive the notification and have like data synchronization between databases, which is Oracle was always great, data replication and sharing. And we could absolutely use that, right?
Yes, you can then piggyback on this other feature. Yeah, in general, the Oracle database is really very feature rich. It has it has triggers, very, very sophisticated triggers as well. For example, like when we talk about now, let's say I have this serverless platform that scales to zero and can wake up applications and so on, right? One of the areas where we are building here also on top of the Oracle database is where we are exploring to build a workflow system where you're capturing application state. You're storing it somewhere, but then you use a trigger in your Oracle database to wake up your application to execute the next step of the workflow. I mean, if you, for example, say, I have an email notification or an email subscription service, it is sending the confirmation email to the user. Then it is snapshotting itself. It is then sleeping, and it will wake up as soon as a certain column in the Oracle database says, yes, this is confirmed now. The email is confirmed now, right? So you can piggyback here on potentially very powerful mechanisms around triggers and transactions that the Oracle database has, and use this to enhance the capabilities of your serverless platform.
Then it's a true cloud, because most of my projects right now look like this. So we have AWS Lambda, Java, and someone stores an object in S3. So event is emitted. The Lambda wakes up and can process the event and store it in another S3 bucket. But now we could do the same with Oracle database. Someone changes a table. Now there's a trigger. A function wakes up, consumes the data, and stores something in a different table. But the cool story is, I think you're already talking about durable functions. So what we could do is we could store the state of the function itself in a database. So we could have long running workflows, right, without doing anything.
Yes.
So without the workflow engines or the the function will keep state, and the state is going to be stored transactionally in Oracle.
Yes, exactly. The Oracle database becomes naturally your workflow system. With capturing and snapshotting that application. Yes, absolutely. And I mean, yeah, this is very much what we currently develop. We have already prototypes of some of this developed. Like we can showcase simple workflows that would snapshot, etc. But we are still we're currently still more developing this behind the scenes and make it more solid before we go out with the first version that users can try. But in general, yes, this is absolutely our current development and vision for GraalVM in terms of instead of making the runtime part a little bit faster or a little bit better here and there, we are more combining that runtime part with the database system and start to synergize across this boundary. And this in the GraalVM project, this has always been a strength of our team, is that we have actually experts across the whole stack in the team. So we have some compiler experts, of course, because we come originally from the compiler area, right? But we now in the team also have database experts that know how to hack and add capabilities to the Oracle database. We have systems level programming experts that know how to snapshotting on the Linux system API POSIX layer, and at the same time we also added the Micronaut team with Kramer and his team that are capable of innovating on the highest level of the stack, on the Java API level of frameworks.
And Micronaut is great. So Micronaut is very similar to Quarkus, similar architecture, and and uses just compile annotations, but same idea. So it optimizes code at compile time, right?
Yes. Micronaut always had the idea to do everything, all of the reflection that would typically be used for dependency injection, to do all of this at compile time, and they are quite innovative in that space. They also came out with Micronaut Data early on, and but it is the case that some of this ahead of time processing features, including on the data connection side, they have been replicated nowadays also in other frameworks like Quarkus and Spring. But in Micronaut, this was always part of a core idea behind the framework, and it's a little bit smaller and leaner, I think, than some of the other frameworks, and maybe has slightly less features. It's slightly less feature complete because the Micronaut team is I think there's less people, let's say, working on Micronaut compared to Spring or Quarkus. But at the same time, this means that it's maybe slightly more opinionated, but also cleaner and has less less clutter to it, I would say, compared to.
So I would say Micronaut and Quarkus are comparable, but Quarkus has more support for microprofile, which is the microprofile is compatible with my older project. So this is why I'm running Quarkus, because the enterprises, I could migrate all the projects to Quarkus, and Micronaut is missing some functionality in microprofile, but it is more compatible with Spring. So there were some Spring migrations to Micronaut, to save some memory. So this is also, but Micronaut is great. And another project at Oracle is a Helidon, also another great runtime. So, but it doesn't optimize at compile time as much as Micronaut, but still interesting. So Oracle has actually two runtimes, which are great: Java, Micronaut, and Helidon. So interesting.
Yeah, no, absolutely. And for Quarkus, I think one thing to mention with Quarkus is that Quarkus is definitely the framework that's most aligned with native image. So if you're looking for the smallest and most compact native images, the Quarkus team has done most work to really integrate their framework with native image and to all the special tricks to get to the absolute smallest numbers on binary size and memory consumption. But in general, the GraalVM team has good relationships with all of those frameworks that you just mentioned, and we are very happy that we could over the last years work with them to make sure that they are aligned with what we are doing, and there's a good compatibility story for all of them.
A little bit of context or my idea about database cloud. So there's like more than 10 years ago, I was in a project where I helped AS400 developers Java to introduce Java. And they had, the AS400 host machines, so IBM machines. And there was like almost entire world run on a single machine. And we had a chat about, because they were very efficient, highly efficient, and we talk about the architecture and the main difference between the S400 and my Java world was that they had, the transaction manager, the database, and the operating system, everything ran in the same memory. So there was no remote communication between the parts. And you can absolutely do this with Oracle right now in GraalVM. So if you are smart, you can run everything in one single memory. So you could be as efficient as, the famous or infamous host machines, which were highly efficient, but proprietary. But now we can be highly efficient and standardized, right? So if Java runs there, Java 25. So for me, and then I don't care whether my Java code runs on Oracle or in Docker. And I would prefer if my clients runs Oracle to deploy to Oracle before I have to build the Docker image and all the ceremony there.
Yeah, absolutely. And if you run the image directly on database here, also compared to Docker, like your footprint and cold start is just better. Because Docker still has an overhead. It's still a full Linux system. And that's not required because for running a native image, what they're doing actually is that our virtualization layer is more on the POSIX layer. So we look at the POSIX calls, the Linux kernel calls that are made from a native image, and then we map these calls to the database operating system layer, and so it's not we don't need a full-fledged Linux to run a native image. It's actually a much more narrow set of elements that you need to support, and this means that your general overhead of kernel data structures and kernel startup that you would otherwise have in Docker just goes away. Because this is something we also learned when people started to deploy their native images in containers and so on, is that, well, native image starts so fast and is so lean that suddenly the container overhead becomes a dominating factor. And in our setup, when we run the native image directly in the database and managed by the database, this goes away.
Okay, so you are really considering the Oracle database as a operating system, right? So
yes,
which is perfect. So a tight integration. One missed opportunity, I think. So what I see in my larger projects is interest in local inference. And all of my clients run Java, and usually even Amazon uses Java for they have DJL for inference to save costs, basically, because Java runs faster and more efficient than Python. And there are efforts like Tornado VM, and I would say maybe it would be also interesting, to focus a bit more on local inference for enterprise projects, where you can say, look, you don't have to install, the entire Python dependency, I would say hell or whatever. We can have one file, we ship GraalVM with the model, and you can have inference, which could be also serverless, basically. It has to be even. And I would say huge opportunity here.
Yeah, I agree. When we say running inference, I think one thing we need to distinguish is, are we running it then on the GPU or even on the CPU, right? Because if you, for example, talk about running serverless functions in the database, then you would run on machines there that don't have a GPU or that don't have a strong GPU to begin with. So for doing inference, for example, locally in your Oracle database, you would run you would try to run it on a CPU, which for smaller models can also work quite well. And this, but I mean, this type of CPU-based inference, this works with GraalVM today. Of course, you can use your. We've also this project where we had the Llama 3 implementation in Java, and it runs pretty with native image. It runs efficient and competitive with anything you can get out of your C++ compiler. So performance wise, this is totally fine. But this is for CPU based inference,
which is also interesting because I think models will get smaller and more specialized. So this is covered. So you will need to know and very good vector support, right? From SIMD support.
Yeah. We have the SIMD support. We also added now the full vector API support that we were missing a few years ago. When we did the 1 billion row challenge, that was one of the missing features actually. But Grind was still the fastest even without that. But we added more vector support there. That's one aspect. Now, yeah, but in general, if you want to now go to the GPU based inference, then yes, our recommendation is to go with something like Tornado VM. Where Tornado VM is by the way also built on top of the Graal technologies. Tornado VM is built on the Graal compiler. This is the Graal compiler to offload to the GPU, and so Tornado VM would be I think the choice here to then run GPU based inference on with Graal, right? Now. And then smaller models, of course, yes. For smaller models work fine also on CPU. I mean, you can use small models for maybe some sentiment analysis that's more sophisticated or similar, or some smaller classification tasks or data cleanup tasks, let's say. And for these type of tasks, a small model with a few billion parameters is fine, and you can then build that model into your image if you want. Like from a deployment perspective, yes, native image has the capability to directly add data into the image and start the JVM program right with an existing heap. And if the model is smaller than a gigabyte, let's say, then yeah, you could just bake it into the system, right? Now, in terms of the languages, right? Yeah, I mean, you mentioned yes, so Python. You don't want to do everything in Python, etc., which is true. But I think one important thing to mention here is the feature that with GraalVM Polyglot you can get is that you can actually from your Java program run also Python program or Python code if you want to. And this comes out of our very long-standing work on Polyglot. Where we are primarily at the beginning, we were more focused on JavaScript. You can embed JavaScript into Java with GraalVM, but we expanded this lately specifically for Python as well as WebAssembly. And these integrations allow you to use any Python package you want, including native packages. From your Java program. So this can be useful if you have an existing Java stack and you want to use Quarkus, Spring, or Micronaut for your server-side application because you want to use Java there because of the rich framework. But at the same time, you might want to use some library that is available only in Python or whose primary version is available in Python. And in such a setup, you can, with GraalVM, actually combine those two things without managing a separate microservice because of it. Because otherwise, the only way to do this is, well, I now start two processes. I have a Java process and a Python process, and they communicate with each other. And you need to start managing lifecycle of those two processes, and and memory management of those two processes and so on and so forth. So that's very complicated. But with GraalVM, you don't need to do any of that because you can just manage one heap for Java and Python and JavaScript if you want. And you can access all packages from Python. You can access also all packages from JavaScript. And this can be super, super helpful in certain scenarios. And we're talking not only about, LLVM frameworks from Python or something like that, but because the LLVM inference of a strong model might anyway kind of be out of process. But we're talking about use cases like pre-processing some data for an LLM. We have in Python very mature libraries, Markdown and Dockling, that can do this pre-processing of data. And these are the type of Python libraries that you would be nice to have access from Java. And the current way this access is done is you have, for example, in Quarkus, you have a Dockling extension. But what it does is it starts a second server with a Python program and then communicates over the network with that second server, which is kind of awkward. Yeah. Whereas with GraalVM, you can directly call these APIs and you can directly interop with them. And this is a feature that has gotten more mature in the last couple of months.
It started. You could use it as a replacement of the JavaScript engine Nashorn, which was available in Java. So you could replace Nashorn with GraalVM. This was my way, of integrating JavaScript back then. And what I use it for in enterprise projects to have some business logic which is easily replaceable. So, and the crazy part is, listeners maybe are not aware of it, you could back then implement a Java interface with JavaScript. So you could invoke, you can have it still works with GraalVM. So you can have a Java interface and let's say load JavaScript, which and then your Java code will call a Java interface, which is actually implemented by JavaScript. I have no experience with Python, but I would expect this possibility with Python as well, I guess.
Yes. Yes. This is the same possibility there. And yes, we do support all of this type of interop in both directions.
Because of Truffle, right? Because of
Truffle, yes. The Truffle framework is in between. There is a very mature framework. We developed it also, including support for Ruby and R, for example. So it's really multilingual. So this type of interop is very seamless, and you can sandbox the execution of this JavaScript or a Python program, where you can set, for example, execution limits, memory limits, and so you can control what is executing there. And our JavaScript engine is quite widely used. I was at some point, we were doing some search on Maven Central. How many open source projects that are publishing on Maven Central depend on GraalJS, and it's more than 300. So there is many different projects that define GraalJS and its integration as a dependency. Now with Python, it's still a lower number currently because our Python implementation hasn't been that mature, like a year ago maybe. But this is changing right now, when our Python implementation gets a lot of focus, and we expect a lot more usage also for this Python polyglot integration with GraalVM. And the final aspect of polyglot integration is WebAssembly. So we can run WebAssembly. You can use a C, Rust, or Go library if you want, and you compile it to WebAssembly and you call it again seamlessly from your Java application. At the same time, we also can create a WebAssembly image out of your Java application. So a native image typically creates a native binary, but it can also, as an output format, not create a native binary, but a WebAssembly binary that you can deploy on your favorite WebAssembly edge deployment runtime, for example. Right? So this enables you then to bring Java to places where WebAssembly can run, which includes, among other things, of course, the browser. So if you're looking for an efficient way to run some Java logic in the browser, then this is also an interesting cross compilation that we offer with GraalVM native image.
Not only browser. So what an enterprise feature is to run, a WebAssembly on the edge, because it is in kind of a cache or gateway, and you have, for instance, often only modify some headers or add some header stuff, and like Cloudflare workers or something like this. So you need a WebAssembly, but as a Java developer, it's a little bit awkward. So, but if you have one project, with GraalVM, you can absolutely create the WebAssembly out of GraalVM. And this is what I thought, missed opportunity is not for your team, but from Oracle Hire perspective, because what I will do is I would say, okay, Tornado VM is already great, and I would try to join forces with Babylon team, for instance, say, hey, Babylon and GraalVM, and have a stellar GPU support. It doesn't have to be NVIDIA, whatever comes, because I think who knows what happens with NVIDIA. It's this very similar story to some microsystems, right. All the competitors, there are TPUs, and there are lots of CPUs, and I wouldn't be surprised that Oracle also works on something. They everyone would like to have own silicon to have a cheaper inference, and of course there is supply problems, bottlenecks with NVIDIA, so there are not enough chips available. So, but with that, I could use GraalVM to have very good inference on GPUs, and the work is half done because Tornado VM is working on it, Babylon team, and this is what I'm missing a bit. And of course, you are part of the Oracle database team. This is out of scope. But from the Oracle perspective, I will absolutely extend GraalVM in this direction as well. And what's also interesting with your GraalVM WebAssembly support is with that, we almost have something like Cloudflare, right? Because we could have, actually, with GraalVM, we have the Oracle database cloud, and on the edge, we could have a part of the logic executed directly on a cache. With WebAssembly, if there's a cache miss, we can go to the mothership, right? So this is actually a complete new architectures, which would be possible with Java 25 for me. And this is incredible. I think this is like with relatively old technology. What Oracle is, I don't know, 30 years old or something like this. You could overtake, the entire new development and everyone just, with a new concept.
Yeah, absolutely. And I mean, yes. So regarding Tornado VM, we have been collaborating with the Tornado VM team for some time, and we're happy to support them. It is the best way to run Java on the GPU right now, for sure. Mm-hmm. And so we are actually we are in close contact with Tornado VM, and I agree that this is a very interesting feature mm-hmm. that you have been developing, and mm-hmm. and yes, and similar as to these edge functions, I think it would be like the technology that we have here would be very fitting. Now, in the case of executing a native image on top of the Oracle database, however, we don't necessarily need to go to WebAssembly because mm-hmm. we can just directly execute the native image there. And what we developed in this area is we developed a system where we can run native image binaries with isolation properties that are similar to WebAssembly, but it's still machine code. Mm-hmm. So this is based on the Intel memory protection key mechanism that allows you to have memory protection within the same process of parts of your execution in user space, and this type of approach allows us to then to execute the native image directly in a sandboxed fashion, without having to go to WebAssembly, which does have some overheads in terms of execution, mm-hmm. Because it needs to check boundaries and so on and so forth. But the WebAssembly target for native image is still interesting for cases where, well, you have a Cloudflare worker, or you have some other system that requires WebAssembly as input. And in that case, native image is your best bridge to run a Java application or a JVM-based application in this type of setup.
Or even validation, pre-validation, whatever, right? So there was always the idea you have one single source and you could generate, something like a proxy to the edge, and from there, some code to the cloud. This is one of the features, or why I used, for instance, Nashorn back then. What we are able to do is have JavaScript validation directly in the browser and use exactly the same code and run this same code on application server. So we had one JavaScript base reused twice, right? So and now we can do this with WebAssembly, for instance, and this complete new possibilities or lean use cases which were not possible back then. And I think Kubernetes is also able to run WebAssembly directly without Docker. And this is also an interesting part. So we have, some Kubernetes for unknown reasons outside of the Oracle database, and you can have then some processing there and just go to a database if it's really needed, for instance, right?
Yeah, absolutely.
So great stuff. So to have a hello world in WebAssembly, so I will need the GraalVM project, right? So and
it is a you can do this with you download the regular GraalVM distribution, and you just select WASM as your target.
Okay,
it's just a flag. It's just a flag as you build the image, and it's just another backend.
On the podcast here, I had Alvaro, who uses Quarkus to implement a Postgres operator on Kubernetes, and he used GraalVM and he mentioned, so the image was too big, and then he got from you a magic argument, I think was -v or something, and this argument, with this argument, the image size got smaller, but the startup a little bit longer. So there is a trade-off. So you can optimize the size of the native images, and he was more than happy. So I would say there is a lot of hidden features in GraalVM which you can use, and but this was incredible. He told on this podcast, I forgot, but this was a significant image size reduction. And now I think the entire operator is like 80 megs right now.
Yeah. I mean, there's many flags on GraalVM. The problem is like, well, whenever a programmer adds a feature to GraalVM, he adds a flag, right?
Yeah, of course.
And that's how you then end up with many knobs that you can potentially turn, right? Now for the size reduction, we do have one flag which is -OS, S for size. Where we are trying to optimize for size. Now, but this has, as you mentioned, this has some trade-offs in terms of peak performance impact. A better way to reduce size is to first you can use profile guided optimizations with GraalVM native image, because if you're creating a profile, so the way it works is you create an image that's instrumented, you run the instrumented image, it creates a profile file, and then you create the optimized image. So your build step gets a little bit more complex. But if you have that, then as we build the optimized image, we are automatically reducing the size of code paths that is not hot. That is code paths that is not frequently executed based on the profile. And this alone is typically getting you the size reduction. And in this case, without performance penalty even.
Okay.
Now, we also have a build report feature where you create a build report that tells you in detail which libraries take up how much space in your application. And there, replacing a library or cutting off a library from the image can also be quite effective. It also shows you the resources that ended up in the image, which in some scenarios can also take up a lot of.
How much can you save roughly? This is of course depending on application, but let's say a typical Quarkus or micronode application, and I would really like to aggressively, save the size. So how much can you cut off in percent?
So I think
roughly?
from the default configuration, if you go to O size, it should be about 50%.
Wow.
So about half the size.
Mm-hmm.
And if you're going with profiles, then you keep the peak performance and you save about 20-25%.
That's incredible.
Yeah, because typically about 50%. What's very interesting is typically about 50% of your application code never gets executed, because it consists of some debugging code or some code paths that were just never there, and so those really just need to be compiled in the fastest and smallest form possible. Now, if in general size is a very big deal for you, what we recommend actually is to use a binary compressing tool. There is a free one called UPX that, funnily enough, was also developed in Linz University, which is the university where also some of the original parts of GraalVM were developed. But this binary compression tool UPX, it is essentially zipping up your binary. And it's compiling the extraction into the binary, so it's just automatically extracting at the start. And this way you get another about 3x reduction in size.
Wow.
So this is what you would recommend if the binary size is your biggest factor. Also, if you create a Docker image, for example, then Docker image also are compressed or zipped anyway. So then maybe the binary compression is maybe not that important. Now, a further way to reduce size and memory footprint per instance is a feature that we also developed over the last couple of years, but it's available currently only in experimental form, which is native image layers. You think about it as like Docker image layers, but for native images. And this means if you have, for example, many different Micronaut applications, many different Quarkus applications that share a base of libraries, then you can create a shared library for the base. And then when you deploy your application layer becomes much, much smaller. We are getting that down to like a few megabytes for the application layer of a Micronaut application, for example. And this sharing is on the binary size, but this sharing also is on memory. Because when the operating system then loads these applications on the same server, then it can share the memory that was required for loading the base layer.
And this is incredible, in serverless and scale to zero scenarios.
Yeah, exactly. In scale to zero and serverless scenarios, this can save a lot. Because if you have hundreds of applications sometimes that would have the same base, the savings are very significant. And we get that down to about 10 megabytes in cost for per application. So per application, you only have 10 megabytes in cost, and even that cost you only pay when the application is active and not snapshotted, right? So this is the area, and the native image layers. It's not yet a full production feature because we are targeting. It requires some interaction and some coordination with the frameworks to make it work well. But you can expect this also over the next year or so to come out of experimental status, and then you can further save on the per application instance cost of memory and binary size.
I had an argument with an architect recently, and he tried to convince me that the only memory savings on GraalVM are because of the garbage collector. He said that if we have a JVM with a given garbage collector and we use the same garbage collector, we would use the same garbage collector on GraalVM, a native image, there will be the same memory consumption. I say, I cannot believe that, but I say, okay, whatever you like.
That's definitely false. That's definitely false. The memory savings are so the first level of savings are primarily not because of anything related to the Java heap at all, but they are related to the metadata, memory required for metadata. And when I say metadata, there is the metadata of the loaded classes. So the class files, bytecodes, names of the classes, names of every method, name of every variable that is required to be loaded and kept in memory in a dynamic execution. And in our execution, it's just not there at all. And the second area there is profiling data. So when you execute your Java program on a JVM like Hotspot, it is gathering profiling data, which means for every branch, it is gathering the how often was it taken for every place where there's an instance of. It is gathering what types occurred there, and this profiling data also is extra memory related to your program that has to be kept. And we don't profile in native image, so there's no profiling data. So saving on profiling data and metadata is the primary factor of memory savings. But these memory savings, of course, they are proportional to the size, the number of classes in your application. They're not proportional to your user heap, which means that the savings there, they are very dependent on the type of applications you deploy here. If you have an application that requires a 50 gigabyte heap, then the savings from the metadata savings are going to be very small, because the metadata on a typical Java application is between maybe 200 megabyte to 1 gigabyte. And this is what you save.
And profiling data? And how much is profiling data?
I haven't measured the exact distribution between profiling data and JVM metadata, but it should be about the same. So both of it should be similar in size. But it is a constant, and it doesn't depend on how much your Java application allocates. But if your Java application allocates relatively little, so your Java application only allocates a couple hundred megabytes or maybe a gigabyte of heap, then these savings become very substantial, because then that constant overhead from the code metadata and profiling metadata becomes very very substantial. And this is where we see the largest memory savings, where I think on a Spring application that's configured with a small heap, you can see up to 3x or something. So this is the largest part of the savings. But that being said, it is also true that our garbage collectors in native image have smaller object headers than Hotspot. So specifically when you use the serial GC, which is a simplistic GC, again, it's only recommended to be used for smaller heaps. But there, our object headers go down to 32-bit. Now, the object headers in Hotspot, they're starting to catch up a little bit with Project Lilliput and so on. But they're still in native image even smaller. And these type of savings, they are, of course, proportional to the number of Java objects in memory. So they are proportional to the to this user data, and then of course when you look at the overall consumption, you see both of these savings.
And amount of classes, the more classes and reflection I'm using, the more cache is built up, right?
Yes.
Yeah. So it means typical enterprise application with 17 layers and not much cache, huge savings. One class with huge hash map, not that much, because if the larger the hash map cache, the less impact the one class will get, right? So
yes, correct.
Exactly.
Absolutely correct. Yes.
Yeah. Perfect. So we clarified that. It was fun to catch with you, and I hope we clarified, all the how to call it, organizational stuff, but even more interesting, the intriguing database cloud is actually what I like a lot. And let's see what happens. And hopefully some manager will hear that. And what I would expect, that you get 10 to 20 developers more who focus on GPU, GraalVM on top of database. This would be actually a smart move nowadays, to join forces with TornadoVM. And I think the only problem are resources. But if you will get a team of developers, I think crazy stuff could happen, right? With Babylon, Tornado VM, and GraalVM.
Yeah, absolutely. And I mean, we are very focused currently on these database synergies. And the largest part of the GraalVM team is working in this area. So this is specifically the area where you can expect a lot of innovation coming out of the team in the next years. I'm looking very much forward to this because it kind of opens for us a really new opportunity here to make here the Oracle database an even better place to run things, and in this case, make the Oracle database a place where we can run logic written in higher level programming languages, and really benefit from this close proximity to the data and benefit from the vast, really, really cool features of the Oracle database.
Absolutely. Where people can find you on social media?
You find me on LinkedIn. You find me on Blue Sky. I also still have an X account. And you can also find me on Mastodon. So all of this, please connect with me. Yes, I'm happy to accept connections on all of these platforms. And also, if anybody of your viewers has some, of your listeners has some feedback related to, or some ideas, some feedback to GraalVM, some ideas on how we can further define the GraalVM roadmap, I'm very happy to hear that.
So if they would like, to have GraalVM running on GPUs, right? So they should shoot you an email, and
yes,
you will,
yes, and help us with defining the use case, etc. In the whole GraalVM project, we always relied on early adopters and people who were trying our stuff, trying our experimental features, giving us early feedback to help us define our product roadmap. Because as you develop such a very generic runtime, we're very specialized compiler constructors, and we know all these algorithms, but we don't know a lot about like writing enterprise applications or writing really user-facing services. And therefore, we always rely on this feedback we get from the community, and it has been so far really great. And really, I'm really very thankful for this type of feedback we get from people in the field who build the real applications on top of our thing, and tell us like what we gotta change, what we gotta prioritize, what is interesting, what is not interesting.
Thank you a lot. See you next time.
Thank you, Adam.